Okay, what we're going to do is we're going to spend the rest of the class period today going over some new notes, new information, all that sort of stuff. So we wrapped up our tires, wheels, and wheel bearing information. Jonathan, earbud, thank you. And we're doubling down, right? So this is what second semester is going to look like more than first semester. We're going to give you kind of some additional stuff. So when we go out in the shop, hopefully next week, at some point in time, the lab that you're going to end up doing is tire inspection, tire identification, and tire rotation. Okay? That obviously corresponds with the objectives that went with the tires, wheels, and wheel bearings presentation. However, we're going to kind of incorporate a second lab and secondary information at the same time because they're somewhat related to one another. And obviously, we're going to go over alignment, wheel alignment, and that means one group, while all the other groups are doing tire rotations, identifications, and inspections, one group will actually go onto our $18,000 wheel alignment machine and perform an alignment check on one of the vehicles. Okay, and I will help you walk you through that process. It's pretty straightforward though. The machine tells you what to do and you just got to go and do it. And then it'll give you the information and the data, and then you just got to record the data, and then I ask you some diagnostic questions in regards to, hey, if we were actually going to complete this alignment, what would you do next? So nothing too crazy. There is a lot of terms, a lot of vocabulary in this particular presentation because we're going to be describing wheel alignment angles, and obviously what those do and how to fix that, or how to realign it. Okay, so again, with anything, whenever we do notes, make sure you're opening to a fresh blank page in your notebook. Name up at the top. Today's date is the 30th. And then I'm going to ask you to write down an essential question. Something that you don't know or you're curious about, or maybe something that is related to what we're going to be learning. Okay, and that's why we list these objectives. So the objectives for ASE wheel alignment, students, you are going to be able to perform a pre-alignment inspection and measure vehicle ride height. You're also going to be able to describe four-wheel alignment angles, which include camber, caster, and toe, and the effects on the vehicle and the handling and the tire wear. So you can see immediately how this can affect or comes into consideration with some of the information that we just got done learning, right? Because we were talking about tire wear and how we want to rotate the tires at regular intervals. Sometimes it's not the tire's fault that it's wearing out the way it is. Sometimes it's bad alignment. Okay? So again, some low-hanging fruit when it comes to asking questions. How do I measure vehicle ride height? What is vehicle ride height? All right? What is camber? What is caster? What is toe? How does camber affect vehicle handling? You know, where would I correct or where would I align the toe? Again, who, what, why, when, where, how. If you start with one of those 6 and then kind of incorporate some of the information that's on the screen, you're going to come up with a question. And again, just to emphasize this, I know I do this all the time, but I'm doing it now for your benefit later. You're going to be answering this question after we're done with this presentation because you should have the answer to it. Because again, this is what we're going to be talking about. So align your question with this and you'll find the answer later. Okay? Pretty straightforward. And again, because we're doing second semester stuff now, you're going to be typing in the question that you're writing right now for some points in the grade book. So don't neglect this. All right, based off of the amount of non-writing that I'm hearing in notebooks, we're going to go ahead and move along. All right, the only abbreviation or acronym that is going to be prevalent in this particular presentation is SAI, also known as steering axis inclination. Steering axis inclination. The expectation is you don't know what that is. That's fine. Right? That's totally fine. You don't need to know what it is right now. Now, as you're writing this down and getting this abbreviation and definition and all that sort of stuff, I'll let you know this presentation is a little bit shorter than the tires, wheels, and wheel bearings. So I anticipate us going through this today, tomorrow, and probably a little bit on Monday, and that probably will get us to the point where next week, Tuesday, we can get out in the shop and start hopefully doing some of these laps. All right. Moving on from steering axis inclination. The term alignment, what does that mean? Well, very simply, it means to position in a straight line. Okay? If I was you, I would write this down. Alignment equals to position in a straight line. Very simple definition. But it has very, very large implications when it comes to our automobiles. I mean, after all, ideally, if I'm driving down the road, I want everything on my car to be aligned to go in the same direction, right? I mean, that's common sense. But you would be surprised at how often, as components wear out, as things get damaged, as driving conditions change, some of these components are not going to be aligned. Now, to the naked eye, right, if I look at my car, I can say, oh yeah, everything's pointing in the right direction. But some of these alignment issues are very, very subtle. Okay? And you're not going to notice it until it's too late and you notice that your tires are wearing incorrectly. Okay? Or you notice that as you're going down Highway 41 at 70 miles an hour, the car always wants to go to the left. Okay, it's these subtleties that can obviously have larger implications on how not only the vehicle handles and drives, but how it's able to be controlled. Okay?
Wait, would that first one just pull the car apart?
No, it's still going to do its thing, right? And again, this is over exaggerated, typically, right? Just so that way you can see it. If my alignment is this bad, will the vehicle still drive? Yeah, absolutely.
Well,
It will. The problem is you're going to have a lot of scrubbing on the tires because they're going to be going in every single way. So this car is going to be difficult to handle, right? Think about this. If I'm driving this first car down Highway 41 and I have to hit the brakes, is the car going to be predictable in what I would expect as the driver for the car to do? Probably not. And if I can't predict what the car is going to do, that's very dangerous not only for me, but also for those around me. So I want to make sure that everything's ready to go, so that way when I turn that wheel, it's going to do exactly what I want it to do and how I want it to do it. So this is a major deal.
Chris, what are you watching?
Yeah, he's stuck in middle school, so we're just going to let him be. Right? You guys shouldn't even be on your Chromebooks right now. FYI, you can close those lids. We're taking notes on notebook paper. That's the reason why. That's the reason why I do it on paper, so that way I know you're not doing things on your Chromebook.
You got a pencil?
I don't know.
But you have a pencil.
Yeah, you should have one.
No, I don't.
You don't get.
Keep in mind, it's not my responsibility.
Oh, no.
You took it.
There you go. A pen.
You took chances.
All right, correct wheel alignment.
Look at that.
Ensures safe operation, sure handling, maximum fuel economy, and longer tire life.
That's my feet.
Hey.
Mia, why
Sit
are you,
down,
why
take
are you
your notes.
stealing my pencil, bro? You're so weird. Just ask for one.
Oh shit, I forgot about.
There you go. Thank you. So why do we want to correct wheel alignment? Again, we kind of talked about this on the last slide, but ensures safe operation. Okay? Sure handling. I'm going to go left and right or straight. Braking, accelerating, maximum fuel economy. Again, miles per gallon. Important these days. If all my wheels are going and fighting against each other, my engine's got to work harder to overcome that. Just like I, as your teacher, have to work harder in this class to overcome the immaturity and all the things that are going on, right? It would be nice if this class was aligned with where I want to go, and then we could get a lot more done, right? It would be much easier for you and for me. We also want longer tire life. Again, if that tire has a warranty for lasting 80,000 miles, the only way I'm going to be able to get to that is if I have correct alignment. Otherwise, I can slap tires on any vehicle. Hey, it's got a warranty for 80,000. Those tires aren't going to last that long because they're scrubbing. They're going to wear out more. Okay. So obviously, 4 important aspects to why we are doing what we're doing. Why you are learning what you're learning. All right. Here are the 3 fundamental angles of wheel alignment. You need to know their name. You need to know what they look like. You need to know what angle you are looking at in order to view these angles. So this slide is packed full of a lot of information. I would suggest that you draw some of this stuff just to make life faster and easier for you to remember that go back. Okay? So we got caster, we've got camber, we've got toe. We're going to go through and individually discuss each one of these. So I'm not going to spend a lot of time on this slide going through it.
John, why are you not taking notes?
That's John's prerogative, right?
Yeah, I was gonna say, bro.
Why do you care, asshole?
Yeah, when you care.
If I'm not being obvious, this information will be on a test. Like all of it. Okay? Like all of it. You need to know caster, camber, and toe. You need to know what it looks like. What the angle is. You should know how to define caster, camber, and toe.
Is it good?
Beautiful.
That's what I'm saying.
No, mine
Is the
was
camera
fine,
possible?
bro.
Nobody asked you.
Oh, we're going to get into that. We'll get into that. I don't want to introduce that type of information quite yet. We're just trying to offload what is called. Okay?
Mushy.
Now, to aid your notes, caster is viewed from the side.
Ah.
Camber is viewed from the front.
Or back.
Nope, from the front.
Front, buddy.
And toe is viewed from the top.
You can see camera from the back.
Top down.
From that thing.
Okay? Side, front, and top. Caster, camber, toe. Okay, let's move on. All right, let's spend a little bit of time on caster. Have you ever gone to a shopping store like Walmart, Target, Festival Foods? You get a shopping cart.
It's got camber.
Yeah.
Okay, you got a shopping cart. You're pushing it around. What are the wheels called?
Wheels.
Yeah, what's the name for the wheels?
Casters.
Casters.
Oh,
You didn't know that?
Now, hey, if you didn't know that, you get free information today. Okay, the wheels on a shopping cart are called casters.
Why don't you get information?
Guess why they're called casters? Because those wheels have caster to them, a wheel alignment angle.
because they
Okay.
spin.
So, remember, caster is viewed from the side of the vehicle. It is a forward or rearward tilt of the spindle as viewed from the side of the vehicle. Okay? Forward or rearward tilt of the spindle as viewed from the side of the vehicle. So again, if you were to come in here and look at this one, number 1, okay, here's my wheel. Let's see if I can get this to be drawn circular.
Knowledge up there, bro.
Okay, here's my spindle. All right. Now, this particular caster angle, sorry, Braden, I'll get out of the way here in a second. This particular caster angle is literally vertical as to the center of that wheel to where it is mounted. Okay, do you see this?
Yeah.
Straight up and down. That is what we call neutral caster or zero.
You're the best.
Okay, it is neutral. It's neither positive nor negative. It is straight up and down.
This horse is the best.
You're the best.
Okay, that's neutral caster. Negative caster, again, center of that wheel. And if I have this vertical line going through this, going down to the road, anything to the front of the vehicle, where I'm mounting the top of that spindle is called negative caster. Negative caster. Big negative sign. So again, spindle is still mounted at the axle point of my wheel. The spindle atop is mounted forward of this neutral line is negative. You need to know that.
Chief, please write that down.
Okay? Positive caster. Again, if I come in here, right in the center is where this is at.
Yes.
The top of that spindle is behind that center line. So if I can draw an arrow, it is positive caster. Okay? But Mr. Getsky, why is it positive when it's behind? Because we're not necessarily interested in where it's at here or here, but it's literally casting an angle that's in front of the center point of the wheel where it's making contact. That's why it's called positive, because it's actually down here. Okay? Negative caster, it's because this arrow is behind the contact patch of my tire. Chase, you can put the phone away.
Caught you though.
Thank you. I know that's a lot on here to draw. Again, let me just quickly summarize this. Negative caster. We're drawing a line from where this is mounted at the top of the spindle to the center, and this is literally going back behind. Negative caster. Top here, to the center line, we're literally drawing a line down. It's in front, so it's positive. That's one way to think about that, okay?
It's neutral, call neutral.
Neutral is because it's literally in line with the
How do you do
contact
that?
patch.
Do what?
What?
Like the dotted line.
Whoa.
Come on, dude.
It's crazy.
It's not hard.
Wow.
I am.
We just did the same thing, bro. That's crazy.
Yeah.
All right. Again, caster is the forward or rearward tilt of the spindle as viewed from the side of the vehicle. Okay? Just a different way of looking at this. Typically, if you can't see the actual physical car itself, it's going to denote an arrow to indicate that that is the front or the travel of the vehicle. So you can see here that this is going ahead of the tire, so it's positive.
What's the
Okay.
best?
Well, it's not so much necessarily the best. It's how does the car handle in positive caster? How does the car handle in negative caster?
I didn't know what your car has.
Okay. Now,
Look at it.
I'll let you kind of write this down. But here's the fun part: your shopping cart that you take to Target, Walmart, or Festival Foods.
Well, we take it.
Those wheels called casters. Those wheels have negative caster, specifically in the front. Okay. By the way, have you ever gotten a shopping cart where you're driving around and then the caster wheel is just kind of doing one of those things? It's just flopping around. You're like, my goodness, this is annoying. It makes a lot of noise. Yeah? Okay, the reason why it's flopping around the way it is because that wheel is literally being pulled by the caster of the angle, okay? So the same thing would happen in your car if you're driving and you had negative caster. Your wheel would kind of begin to flutter potentially.
Where can you buy
Okay.
a shopping cart?
Yeah, I was wondering
Positive caster, because your mounting point is up top and is behind the center point of the wheel, it's literally pushing the tire, okay? Which means that as I turn my car wheel to turn, I could theoretically let go of that steering wheel, and what happens to the car? Starts to straight back out to go straight again. Why does that do that? Because your car has positive caster. Okay, that's how that happens. Okay, I'm turning, I can let go of the wheel, it wants to go back straight. Positive caster allows us to do that. Okay. So,
Dang, that's expensive.
one thing to keep in mind, I don't even know why you're looking that up, Mason.
350.
Yeah. Shut the Chromebooks, you guys don't need to be on that right now. Easton?
One shopping cart. He's not even on his phone.
I'm not even on my phone. I was sleeping, bro.
Really, should you send an AP down and collect a phone for autos? Thanks, bud. Okay. All right. One thing we got to keep in mind, out of the 3 alignment angles, caster, camber, and toe, caster is not going to wear out your tires. It is not a tire wearing angle. Okay? Again, that's important to link those up. Hold on. Okay. Okay, sounds good. Yeah. Yep, bye. Okay. All right, caster. Not considered a tire wearing angle. Okay? Very important you understand that. Now, the fun part about this is that roads are not flat. Okay? As crazy as that might sound, you don't notice this, by the way, if you're ever driving in a car, driving or riding in a car. But actually, roads are curved.
What?
Okay? They're peaked. In the center of that road, right there, is the high point. Over here, it's lower. Why is that?
So water.
Yeah, water. When it rains out, guess what? We do that so that way the water goes off the road. Okay? And it goes either way. Okay? So it's crown. It's called a road crown.
Yes.
Now, if I'm driving down the road, I want to make sure that my vehicle is going to go straight down the road. The problem is because the road is angled, my car is going to want to go off to the ditch just like the water does. Okay? So if I let go of those steering wheels theoretically, which you shouldn't do, but if I do, and I've got the same caster on both sides of my vehicle in the front, I'm going to go off to the ditch.
Not that quickly.
No, but it's going to have that pull. It's not going to go straight. So what I can do is I can actually manipulate my caster angles so my passenger side is a different angle than my driver's side, which then counteracts that slow pull into the ditch off the road to allow me to still go straight. Okay?
Switch when you're.
Which is kind of fun to think about because how do I know what that angle is? Well, the manufacturer set that from the factory because there is standards on how road construction occurs in the United States. They know what that angle is so they can offset it already for you.
I think
Okay? So again, this is something you need to write in your notebook. A vehicle is going to pull towards the side with the least caster. I should say least caster angle. Just to clarify. Okay? Yeah. A vehicle pulls toward the side with the least caster angle. It's important for a test, yeah.
Are we doing one more slide?
Okay, we're probably not going to, because I still got to explain some of this stuff. So for instance, if I'm driving this car right here, and I've got this road crown, and I want to offset going this way, I want my car to pull kind of the other way. So what I can do is I can actually have a -4 degree caster over here, and I could have maybe a -2 degree caster over here. Which side has the least caster? -4 is less than -2, so my car all of a sudden is going to pull a little bit to this way if that road was flat, but it's not flat, so it's going to offset that road crown to allow me to drive straight.
That's true.
Kind of crazy, okay? Now, I just made those numbers up just to kind of illustrate that we can actually compare and contrast my passenger side caster angle with my driver's side caster angle, and I can already know which side that's going to pull on based off of that information. This is also something to keep in mind. When I go to do a wheel alignment, I'm not having my passenger and driver's side caster the same. Okay? So when the alignment machine says my driver's side has a less degree angle than my passenger side, that's on purpose, and that's the reason why. It's not because it's out of alignment. Okay. All right, we'll end there for today.